take a look at another example. A researcher claims that the number of different colored candies in bags of dark chocolate M&Ms is uniformly distributed. To test this claim, you randomly select a bag contains 500 dark chocolate M&Ms, and the results are shown in the table at the left-hand side. So these are the categories that we have: brown 80, yellow 95, red 88, blue 83, orange 76, and green 78. Do we reject or do we support this claim? Perfect. So what do we have? First of all, we need to follow these steps. We need to identify the null and alternative hypothesis. The expected distribution of different colored candies in the bag is uniform. This is our claim because of is, and alternative hypothesis, which is not uniform, is going to be written here. Now the degrees of freedom is k minus 1, which is 6 minus 1, 6 categories, minus 1, which is 5. Now the degrees of freedom is 5 and alpha is 10%. In the question it's given to us. The critical value is going to be 9.236. So the rejection region is going to be any number larger than 9.236. In the next step, we need to calculate the chi-squared standardized test statistic. You have to observe values: 80, 95, 88, 83, 76, 78. The expected frequencies are 83.33, 83.33, and so on. Now, the observed frequencies minus expected frequencies is going to be negative 3.33, the difference between these two numbers. 95 minus 83.33, which is 11.67, and so on. You're going to raise each number to the second power and then divide each one of these by the expected frequency, which is 83.33. These are the numbers that you can get. So the chi-squared is 3.016. This is the standardized test statistic for your chi-squared, which is outside the rejection region. For those of you who ask how we got 83.33, this is 500 divided by 6 category. So observed and expected. When there is no percentage for expected, you're going to divide the total number of values in your sample by the number of categories. That's the easiest way to do the expected frequency. Very good. So as you can see, your chi-squared is outside the rejection region, and you're going to fail to reject the null hypothesis, or you're going to support the null hypothesis. There is not enough evidence at 10% level of significance to reject the claim that the distribution in the bag is uniform.